Hi, it's Richard here from Intelligent Advisor IT Consulting with another in our long-running series about the example projects from Oracle Policy Modeling. This week, after a brief summer break, we're back looking at one of the more interesting ones, which is the My Store app, which includes a variety of fairly standard features, but also looks at using the location provided by your browser. Anyway, let's take a brief walk through what it is. I'm sure you're very familiar with the idea of going onto an online store and trying to make a return for something you've purchased and describing what the item is and then being told that you can't return it because it's non-returnable or because it's damaged or because you waited too long before you returned it. Those are the core elements of the basic process in here. And then we have a couple of other items in respect of managing the order details for the thing that you're sending back. And then some stuff about returning your item, including a PDF-based form that you can print out to help you package it up and send it away. And then we have shipping calculations to tell you how much this is going to cost, whether it's a free return or not. And then we have this thing called Nearest Store, which we're actually going to spend a little bit of time on later. And finally, a result being the final screen in the interview with a bunch of dynamically displayed labels. But back to the idea of a Nearest Store. I'm sure you come across this where you give your location and then the website tells you, well, your nearest store is so far away or whatever. And as you'll recall in Oracle Policy Modeling, you can set up a screen to capture the browser supplied latitude and longitude. So in this case, in this interview, there are already a couple of attributes here, the home latitude and longitude, which are used to capture this automatically from the browser. If you do it in debug, you'll be set to being somewhere in Redwood City in California. If you do it in a real browser with Control F5, then you'll see your actual location. And let's take a little bit of a walk into the different Word documents from this project. And there are a couple of ones that I think you need to look at. Let's start with Excel, however, and you can see that in this project, the GPS coordinates of the branches have already been added for you, and you can add them to that Excel spreadsheet, but you also have to remember to add them to this Word document which accompanies it. So this is an interesting one. Of course, the store's location is fixed. We know where the stores are. So the GPS coordinates are supplied in the Excel spreadsheet, and the different branches are inferred in the Word document. Once we know what the interview is about, we infer the different branches. So this is an interesting concept, is that we don't always need to find the location of something. If we know the store address, we can find the GPS coordinates and store them hard-coded into our Excel spreadsheet like you just saw. We'll come back to Nearest Store in a little while. The rest of the interview has some very straightforward, well-documented rules regarding translating non-Booleans into Booleans, so fairly standard stuff that we've covered in a number of different example videos. And then we'll move on to the next Word document. So we have some basic ideas for setting up the form that you're going to download. And the overall management of the synthetic goal called the interview is complete. Once we know if you're returning something, if we know which store you're returning to, or if we know that you're not eligible to return. Fairly straightforward, again, clearly documented, well-structured rules, easy to modify if you want to change the logic. Then we have some other ones I'm not going to open, which are substitution and visibility, because we visited those two topics many times. They're just more of the same, well done, and you can easily modify them. And then we have a little bit of a rule about some products are not returnable, which has been inspired by a well-known online and big box retailer, whose name you can see there. And as we work our way through the different files, we'll come down to the next one, which is all about returning and whether the item is too big or whether the store isn't able to take that kind of item. Again, fairly straightforward logic and very easy for you to modify, I would have thought. And the last one is the shipping costs, which I mentioned right on the outset, is that when you return something, it's not always free. So we have a little table here that, of course, you could modify to change the shipping costs. So all in all, a very easy to modify project. I'm going to go back to this Word document now. And this Word document is all about finding where you are. And this might be the surprising part, is that it uses something called the Great Circle distances. And it's simply that when you look at a distance between 2 points, because we live on a sphere called the Earth, it's not enough to just calculate it by a straight line. You really have to take into account the curvature, the spherical nature of the Earth. Those of you who've been watching us for a while will know that we've experimented with the Great Circle Mapper a while back in one of our example extensions, where we use this API called the Great Circle Mapper to calculate the distance between airports. Because obviously when you're flying, if you're flying a long distance, you're flying around the curve of the Earth, so that it becomes even more important the further you go. But what is interesting is that well, Google has a number of APIs, as you know, including one called the Distance Matrix, which is one of the APIs that includes a Great Circle mapping capability. So if you move from A to B, if it's a short or a long distance, you are essentially moving across the sphere of the Earth. So what am I telling you all this for? I'm telling you for this for two reasons. One, I think it's absolutely spectacular that the example project includes the Oracle Policy Modeling implementation of the Great Circle Mapping rule, including setting up constants for pi and the basically. I'm blown over by the fact that they provided this to us, because it's really rather cool, and it's an excellent demonstration about how you can implement some fairly complex mathematics into Oracle Policy Modeling just using the standard functions. Thinking back to how it's applied in real life, it's used to calculate the distance between the store, which of course is one of those stores that we inferred, and your current location. And what that means is that the location, the distance is given to you in either kilometers or miles, based on the spherical nature of the Earth, and you can then see the distance between you and a branch. Where it becomes more standard Oracle Policy Modeling, I would say, is that we need this concept of the nearest branch and then the next nearest branch. If you've been following our long-time series on relationships and logical loops and inferred relationships, the nearest and the next nearest will sound very familiar to you, because it's very similar to something we did a number of times. So it uses a relationship to work out which is the nearest branch, and then it uses the GPS coordinates from the spreadsheet of that branch to work out how far you are away from the branch. And then it can do the same for the next nearest branch. You will probably recognize these. They're all using instance minimum because we're looking at the shortest distance between the two. But it's using a fairly standard relationship management technique that we've used before, and I advise you to go off and look at the relationships series. But here's the trick. Even in short distances, using the calculation that you've seen in the Word document can introduce some errors, because let's say I tell you it's 10 miles from your house to my store. That doesn't take into account traffic, and it doesn't take into account roads. It's really just a straight across the Earth calculation. So it's not always the real answer. So if I debug this interview, what I've done is I've included in this interview, I'll move it into a proper browser window, there we go. In this interview, what is interesting is you can see the coordinates up there. Those are the coordinates of my location. And obviously when you choose, I've displayed those. They're not actually displayed in the standard interview. And of course you would then choose what you want, and we're interested in the nearest store. And it says the nearest store is in London, 16.79 kilometers away from my location. But the problem with that is that it's not taking into account traffic or anything else. So here's an example we used a long time ago to display a map on a Oracle Policy Automation interview. And what we're going to do is we're going to use the same technique that we used in that to basically calculate the real distance between the two, taking into account traffic and roads and so forth. To do that, I'm going to create two new attributes to help me get the GPS coordinates of the nearest store. So I'm going to use a very traditional method. In fact, I'm just going to copy one of the lines that was already there, because it uses a similar technique to pull out the name of the branch that is nearest. So I'm going to go and just use that technique to pull out the latitude and longitude of the branch. And I'll do, so I've done the first one there. Just got to make sure I don't make any spelling mistakes. So give me a moment while I sort this out. So I'm going to use these two rules to populate the latitude and longitude of the nearest branch. Yeah, there's a spelling mistake. I was just talking about that. There we go. And once I've created those two attributes, which will pull in the latitude and longitude of the nearest branch, I'm going to validate my work, and then I'm going to go and add a name to each of those, because I need to be able to reference those in my JavaScript extension. So there we are. I'm going to add a name to this one, and I'll set its attribute type, because I notice it's still set to automatic. It's good practice to always make sure that you've got the right data type. And then I'm going to do the same in the other attribute. Go find it and give it a technical name and change the type. So this will facilitate me accessing them from JavaScript. Now, I could use the JavaScript, the JSON data file, but to keep matters simple, I'm actually just going to display those coordinates on the screen, so I can immediately access them in JavaScript without doing anything else. So I'm going to add a couple of labels here and sort this out. So for my own purposes, I'm going to display those two attributes. The nearest store's latitude and longitude, I'll just put a label on. This is just so that it makes it easier for me in this demo to access them in the JavaScript, because they're already present on the screen. Yeah, looks okay. I'll put a little colon in there, make it nice and neat. And then the page that I was using, I'm going to just remind myself to leave this blank page in my interview for now, because this blank screen does nothing, but it does actually collect the latitude and longitude. Finally, in my nearest store screen, I'll make sure that I include a nice little, so there's the latitude and longitude of my browser, and then I have the latitude and longitude of the nearest store. I just need to change those variable names. So now I have both of those, my store and my location. And in the testing, you can see I actually hard-coded something here. So I'm going to grab those values. There we go. And in my testing, you can see that I actually had a hard-coded location in France, which is where I am at the moment. So I'm going to remove that and replace it with a nice little call to Google to go and get the location, so I can calculate the distance matrix, as they call it. Once I've got the distance matrix, I can then reference to the service, I can call it, and I can say I want to use metric, which is kilometers, and then I can paste it into, I can position it back on my browser window. Let's reorganize this a little bit. Okay, so there we go. The label at the top that says new label is actually going to be replaced by the dynamic response from the Google distance matrix. So this is the one that's actually going to do the magic. It's using interview fetch, so it's asynchronous, so it could take a little while, and it's going to paste into that zone a nice little string of text that tells you how far it is and how long it should take. And we can compare the results of the calculation using the formula and the calculation using the Google Live traffic and what have you. So we can see if there's a difference. So this is just a standard call to Google distance matrix and parsing the response and then grabbing the response and putting it into a label. I've requested it in kilometers. Obviously in this interview, if I wanted to do it in miles, I could do it in miles, but I'm going to just do it in kilometers for now. So we have the nearest branch, we have your location, and then we have the magic label extension at the top, which will hopefully display the real distance and the real time. So I think that's us done. I can go ahead now and launch the debugger. This is an excellent exercise in extending the interview if you've ever used interview extensions, and if you haven't, it's a great opportunity to learn about it. Leave a comment if you're interested. So then I'll go to next, and I'll say I want to find the nearest branch. Now I know that I've captured my location, and there we go. It says this is the live response from Google. It says it's 20.3 kilometers and it takes 15 minutes. Compare that with the formula that says as the crow flies, it's 16.79 kilometers. So in real life, you may wish to use a real service to get you the details. That's it for this one. I hope you enjoyed it. Reach out in the comments in the post or in YouTube, and I'll get back to you with anything you need. Have a good one.